everyone. So today we are solving this problem, remove subfolders from a file system. Okay, so basically what is happening in this question is given a list of folder, return the folders after removing all the subfolders in those folders. So you may return the answer in any order. So let's understand with one example what does it actually mean is and what we are supposed to do. So can you see here I have taken the example given in the question. So let's interpret what it actually means. So for example, see here, take any string here. Let's say we are picking this guy, A and B, right? A/B. Now, who would be the parent folder of this? So if we check here, whatever is there, if we remove this guy, the very last guy, okay, then whatever is remaining, that would be the parent folder. So in this case, for this AB, the parent folder would be A only. For this one, the parent folder would be this guy, A, which is already occurred. Now let's say this is CD, okay, this is C and D, okay. So what is the parent folder of it? So if I remove the last character, basically the C, then what would be the remaining? This remaining C would be basically the parent folder. Similarly, we take this example C, D, E. Okay, this is like this C and D and E. So if I remove the very last one, whatever is remaining would be actually the parent folder of it. So C, D would be the parent folder in this case. Now take the first example A. So in this case, what is happening? If I remove this A, what would be remaining? There would be no character, right? No value, because this is just a backslash, right? So we just cannot interpret. So in this case, when this is remaining only, in that case there is no parent for it. So A doesn't have any parent. Very first value doesn't have any parent. Okay. So what we have to do is we have to remove all those folders which are basically the subfolder of some other folder. Okay. So far you should be very clear that what does it mean to have a subfolder, and we have to remove all the subfolders. So let's do that. Let's remove here. So come here. Let's suppose this is our answer list. So this guy doesn't have any folder, right? So we will not able to remove this. Okay, so this will come as it is. Okay, now come to second guy. That hey, is there some parent folder? Yes, if we remove B, there would be A only, and A is already there in this list, right? That means we have to remove. So this will not be included in our answer list. Now come to this CD. So if I remove D, C would be the parent folder. But is there any C? There is no C. Single C is not at all there, right? Even there are C, F and CD, but we have only single C as a parent. It is not there. That means this guy doesn't have any parent. So this will be basically included. Okay. So this would be included like this. Okay. So far we have included all those guys who doesn't have any parent, means all the subfolders we have to remove. Now come to this guy, C, D, E. So if I remove E, it would be CD only. So hey, is there CD already? Yes, CD is already there. That means this guy is a parent for this guy is a subfolder. So subfolder would not be included. So we are not including this guy as well. Now come to this CF. What would be the parent folder of it? If I remove F, it would be only C, and there is no C in this array, right? That means this guy is also not a subfolder, so it will not remove. This would also included in our answer list. So CF. So this would be basically our answer. Okay. Now why this? Because we don't have, these are the guys who are not actually the subfolder of anybody. Okay. So we were basically checking the prefix of if we remove out of the last character, whatever is remaining as the prefix, basically that should be decide whether it is existing there or not. This is what we have to do. So one natural solution we immediately think of, like we can use a hash map, right? Or hash set, sorry. We can use a hash set to store the prefix of all those numbers, all those characters, right? But here for the most efficient approach and the one which is expected in interviews, I would be going for the try approach. Okay, so this video is solely to solve the try approach. So I will tell you that what would be the approach. Okay, so first of all I will tell you what would my try class. Okay, so let me show you the what is my try class here. So you can see here this trie class, as usual we have, right, in the any trie class we have boolean is end. So if we have is end true, that means there is a end of particular string, right? So is end is the one boolean variable. Then I have one hash map called children, which is basically string, and value is trie, okay, for a hash map. So this is what my trie would be look like. Okay, now I will tell you what is my actual approach here. So this is our input, right? We just discussed. Now we have to go through this. So what we will do is basically we will start storing these values into the trie. So before going to storing them, we have to remove all these things, right? These backslash. So backslash, when we will traverse through this array, we can easily remove the backslash. So for example, let's say our trie would be look like this. So let me draw the trie initially, how it would look. So initially trie would be the root. It is rooted somewhere. So this would be our root, and this root would be having what? So any trie has one value is the is end. So by default this is end is basically false, right? So initially our root would be anyway false. So this is end would be f. I am writing just f, and children is also by default it is just created, right? Our hash map. So say I am calling it ch, okay, children map. This is what initially it is, correct? So this is empty only, correct? And this is by default f, false. Now what we will do, we will take this first guy is a, right? So we will convert this, whatever it is, it's not necessarily a, we will convert this to the equivalent string array. So we can do split, right? So with the help of a split we can convert this to array. So for example, in this case this would be one character a, right? Like this string would be like, looks like this. Okay, now what we will do is we will store this value into this trie. Okay, this is our trie root, so we have to store it. So what we will do, we will go to the child of it, we will check, hey, is there a? No, there is no a. That means we have to create a here we have to put this value, right, in this children. So we will create a new value. So this would be like this. So we will have is end everywhere, right? This is also a node only. So is end would be like this. So is end by default, so far it is f. Okay, so let's update it, and then this a, this would be our hash map thing, right? So a would be the key. Okay, a would be the key, and the value would be again another node of trie. So let's take like this. So it would have some by default values, right? Is end and that thing. So this would be again having is end, and again having the children ch. Okay, so now what happens, we stored this a. Okay, now when for the next pointer we will come to this place, right? After storing it we will come to this place, but by that time there is no more value in this a, right? Because this is of one length. So our pointer is right now here. So we are done till here. So what we will do when we are done till here, that means this is the end of this string. So we will make this is end equal to true, because this was the end of the string. So far we have stored like this. Now we will go to the next value. So what is the next value? So we will again convert the equivalent string array of it. So split based upon the this backslash. So how this would look like this, a and b. Okay, this would be looks like a comma b, just creating the corresponding array, string array of it, right? So we are going this way. Now we will again store these values. So we will go to the root. So in the children, hey, does it contains a? Yes, it already contains a. Okay, so if already contains a, then we will our pointer come to this point. Okay, then next value is b. So we will check there, hey, whether this current pointer is red icon here, does it have b? No, it doesn't have b. So what we will do is this would be again creating a value. So key would be like this, key would be our b. Okay, and the value would be again a node, right? A node of trie. So this would be like this. Okay, and this would be also is end. Okay, so because this is also the node of a trie, right? So is end. So now b is the last pointer, right? So B is the last character, so is end will become what? Is end also become here true. Okay, and this would be our children. Our children would be the this empty stuff, right? So we are done. We have stored A and B and this thing. Now we are coming to the next guy. This is our CD, right? So our when we convert it into the corresponding, these values basically would become C and D. So let me make them C and D. So this is our C and D. Now you will come here, root. That does it contains C? No, it doesn't contain C. That means we have to create a here only, like parallel to this in the same children array, right? So this time it would be like this, C, okay, and C is connected to the value what? So it would have like this. So let me remove this array. So just like we stored A, similar way we have to store the C as well. Okay, so C, and it also would have edge end. Okay, so I am putting it edge end like this. And this also would have a children array, right? And this children basically have the as of now an empty string because we stored the C only so far. Okay, now after doing the C, we will come to the next character. So this is D. So our current pointer would be here, right? So we will go to here. So what will happen here is yeah, so here what will happen, edge end, here also the edge end would be there, right? So edge end, and B will store here D. So D will also point to this kind of empty node. Okay, now edge end, because this is last character, so this edge end also will become true. So I am just giving the internal storage of the trie, right? So we have stored edge end, so C and D is also stored. Now we will come to the C, D, E. So when we will come to the root, every time we will, whenever a new string starts, we start from the root, right? So does it C have? Yes, the very first has the C. This children has the C, so C was there. Then we will go to next character. Our new value would be C, D, E, right? For this guy. So C, D, E, C is there. Then we'll go to next character. D also there. Then we'll go to next character. So next character is E. So we have to make this edge end. Okay. So this edge end also become what? This edge end also will become the true, right? Because this is our last value. And this guy would be C, right? So sorry, C, D, E. This guy would be E. And this E would be basically indicating to another empty node. Okay. And this edge end is become now true. So we have stored C, D, E as well. Now come to C, F. Okay. So we'll check, hey, C is there? Yes, C is already there. But it doesn't have F in the next character. So here in parallel, we have to store F as well. Okay. So this would be our edge end. And our edge end basically here it would become true because this is F, right? C is already there. So this guy would be, edge end would be true here. So let me put it true. And this would be F, right? So our F would be the key, and this guy would be value would be an empty node, right? So this is the way of storing these values. Now we have stored all the values into trie. So what is the next thing? So we will look for the next thing. So what we will do, we will again go through all of them, right? Now we will check for all of them. Okay. So let's say we are again after storing, we are coming from here. Okay, we are coming from here. Okay, so we are again, we will convert it to this corresponding array. Okay, so we will start from here at the root, that hey, A is there. Yes, A is there. Okay, so A is only one character, then this is true, right? This is and is true. So for one character we came out of it, because this is not a subfolder, because nowhere we found earlier values, right? So for one length we came out of it, and each end is true. That means this is one complete thing, right? Our for loop would be run only one time, so it doesn't have any folder. This guy is not a subfolder, correct? So we will add this guy A into the answer list like this. Okay, whatever value we had, so we will add it like this into the answer list. Now we'll go to the next guy. Next guy is AB. We'll come here. So does it have A? Yes, it have. But before coming to the B, before coming to the end point, we found a true here, right? So we found a true here. That means there is already something occurred. Who is the parent of this guy? So if parent of this guy, that means it is saying this guy is a subfolder. And if this guy is a subfolder, we don't have to add into the our list, answer list. So we will continue. We will come to this guy. Okay. So we will come here again from the root. So is there C? Yes, C is there. Okay. Then is there corresponding D? Yes, D is also there. Right. So far we didn't find this is end is not true. And D. So this is true. But till the time we are at the last point. That means nowhere till the last point we didn't find any earlier true. Correct. So we will say that this guy also doesn't have any parent. So it would be added to the answer list. So let me add it to the answer list. This guy will also come to the answer list. Now we'll go to the next guy. So this guy is C, D, E. So hey, we will come to the C. So is C there? Yes, C is there. Is D there? Yes, D is there. But there is a true. So before coming to the E, we found another true. First true. So that means there is already a parent. So we don't have to add this guy also. We'll go to directly for the next guy. So CF. So C is there, right? And the next value is F. So next value F is also there. And before reaching F, we didn't find any true. That means CF also doesn't have any parent. Okay, so it is not subfolder. So CF would be also added to the answer list. Okay, so this is way finally we are getting our final answer list. We have removed all the subfolders, right? So as you can see, this was a very simple explanation if you look carefully. Okay, so here we are doing this with the help of trie, and using tries is considered very efficient way, especially for these kind of string manipulation questions. So I will show my corresponding code for this. This is my trie class, which has the is and the has map string and trie. So this is as simple as that. Then this is my corresponding code where I have created one root node. Okay, I'm assigning it into our constructor of solution. Then this is our method. Okay, so what I'm doing is, first of all, I created one answer list where I will park all my answer things. Then see here what I'm doing. I'm traversing through the folder, right? The way which we were traversing here. This is our folder, right? So I'm traversing through this folder. I'm creating the string array, splitting on the backslash. Okay, just we were doing here, right? I created one intermediate array. We are doing that part here. So split it based upon the backslash, and then this is my trie. Okay, so in trie I am starting with the trie char equal to root. Okay, so now what we are doing is we are taking whatever value we have taken in this folder in this string array. Okay, now what I am doing is, if there is a null value, then no problem, we are just continuing. Otherwise what we are doing, first of all we are checking that hey, if this current dot children dot contents doesn't this character, the first s is not there. Okay, just like we were starting here when we were inserting, right? So we will check. See here, we are whenever we started, we are starting inserting from here, right? We were checking if it is doesn't exist, we added that. If it already existing, then we were going for the next pointer. So same thing I am doing here. So if doesn't exist, add that value. Otherwise go to the inside it. So current equal to current dot children dot get s, whatever the next node in that. Then when we are coming out of this, we are adding that cur dot is end equal to true, because we are at the last character of that thing when we are inserting. So at the last character we have to character we have to add it as a true, because this is the end of that string. Okay, now we are done in this part. We are done storing of all of them, right? We stored all of them. Now next thing is what we are doing. Now again we are traversing through this folder and getting again same way the corresponding path, right, for all those strings, right? So what we are doing, initially I am making this is subfolder equal to false in one variable. Now what we are doing here, we got the value a, right, as an array of the strings, right? Then what we are doing here, we just going continue if it is a null string. Otherwise, see, if we found any is end equal to true, okay, and our length I is not at the last character, okay. So if I is not at the last character and still we found prior is end equal to true, that means there is a some parent already. That means the corresponding this value str is actually the subfolder of somebody. So that is why I made this is subfolder equal to true. Okay. Then what we are doing? Current equal to current.children.get AI. Okay. We are going for the next thing. So see here, when we are coming out of this for loop, we have already stored this value, right? It's subfolder true. So if this is subfolder is true, that means we should not add. But if it is not true, means if it is not the subfolder of anybody, then we are directly adding this substring where we started from the folder, right? Because we need to store as it is with the backslash. So if it is not the subfolder, I have added it into this thing, answer list. And after doing all this, we are returning this answer list. So this would be my approach. And here we are using the trie, so time complexity would be of the quadratic O of n square, and similarly the space complexity also would be the O of n square. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.